going to do lesson 3.7 on reflections and symmetry, and then also lesson 3.8 on rotational symmetry. So a reflection is a transformation that flips a figure over a line. This line is called the line of reflection. Sometimes the y-axis or the x-axis is used as the line of reflection, and sometimes they give you another line to draw for that. So let's look at our first example. Graph triangle BCD and its image after it is reflected over the line through 1, 3, and 1, 0. Name the vertices of triangle BCD prime, which is the image that we'll end up with. So, all right, what's our first step? Our first step is to find what line we're going to reflect it over. And so it tells us to do it over the line that goes through the coordinates 1, 3, and 1, 0. By looking at that, I can already see that they have one number that is the same, which is their x coordinate. So I know right away where I can expect to draw this line, but let's make both of our points so that way you can see it as well. So I'm going to come to my origin and I'm going to go to 1, 3. So over 1 and up 1, 2, 3. And then I'm going to do my second one, which is over 1, and then I don't rise at all. So what line goes through both of these spots? Well, it would be, okay, now that I have my line of reflection, I want to reflect this image. And the image is going to, it's like holding a mirror. If I were to hold a mirror up on this line and reflect it, and you would see it, everything is going to completely flip over. So the way that we're going to do that is we're going to take it vertice by vertice, just like we did when we were transcribing. So let's count how far away from the line of reflection the vertice C is. So 1, 2. It's 2 going to the left, so I'm going to put it 2 to the right. 1, 2. So this is going to be labeled C prime. Now let's do B. 1, 2, 3, 4. And I almost made a mistake. I almost only went to the Y. I have to make sure I come all the way over to this line I'm reflecting from. So let's try again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I'll label that B prime. Let's do D. 1, 2, 3. 1, 2, 3. And then my last step, as always, is to connect the lines. And now I have reflected the triangle BCD over the line that goes through 1, 3, and 1, 0. Now my last step is to name the vertices. So B prime is going to be located at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, positive 6, 4. C prime is at 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. And D prime is at 1, 2, 3, 4, up 1. And so now I have completed that problem. All right, all of the lessons on reflections, it also might ask you to find a lines of symmetry. Remember that a line of symmetry means that you should be able to fold the image over on top of that line and it will completely fall on top of each other to make it work perfectly. And we'll do some examples of those in class. All right, 3.8 is a little bit more challenging, and there's going to be another video I'm going to have you watch that shows a different way to do this, but first let's talk about how your book shows you how to do it. So a rotation is our third type of transformation that we're learning about, is a transformation that turns a figure about a fixed point called the center of rotation. A figure has rotational symmetry if it can be rotated 180 degrees or less and exactly match its original figure. Rotations change the position of a figure, but not the size or shape, which is the same as with reflections and also with translations. The angle of rotation is the number of degrees the figure rotates. A complete rotation is 360 degrees. So here's the center of rotation. This is what's staying the same. The center of rotation is like if you put your finger right here, that would be my center of rotation and the paper would rotate around it. Okay, that's the center of rotation. So the center of rotation for this image they're saying is here. If it were to go 90 degrees, it would flip a quarter of a circle that way. And we always rotate counterclockwise unless we're told that we're rotating clockwise. 180 degrees would be it flipped upside down, but notice that because the center of rotation is here, the figure isn't on top of itself over here. 270 degrees is 3/4 of the way around, and 360 degrees is a full loop around. So, first type of example can say, find the angle of rotation of the figure. The image matches the original after 1/5 of a complete rotation. So they're telling you that if you go 1/5, that will be the complete rotation. And we know that there's 360 degrees in a full rotation. So we're asking basically what is 1/5 of 360. So we're going to do 1/5 times 360, which equals 72 degrees. So the angle rotation after we were to rotate it after 1/5 would be 72 degrees. You can also use the coordinate plane to graph rotations. So in this book, all of them are counterclockwise. We already talked about that. And these are the steps. You would have to have 2 pieces of paper. You would draw the triangle that they told you. You would have to mark the points by pushing hard with your pencil. Then you're going to rotate and mark each vertex. And then you're going to connect the lines on your new vertex, and that will from vertex to vertex to show you your new image. There's another way to do this, and that involves just following some tricks or some rules that you can use to do each of the degrees. And there is a second video I would like you to watch on those rules. Make sure that you take notes on the rules because that's a lot easier than always getting out extra tracing paper and whatnot. We can just memorize those simple rules. All right, that's all I have for you. So go ahead and get to work.